of our elements here, and with this in mind, is that perhaps ideally each of these we should be able to capture them with a single variable or a single descriptor. So if we look at, say, the physical chemical environment, sea ice, here we list both extent and thickness. And if those are separate and need to be considered separately, then really we should have two categories for sea ice and not one. If one of them is adequate, in other words, if we consider sea ice extent, and that, yeah, it doesn't include thickness, but it gets most of what we want, then maybe sea ice extent is adequate and we don't need thickness. On the other hand, it may be that we find that summer sea ice extent and winter sea ice extent both need to be considered separately. So again, we need to give a little bit more thought as to how we might capture each of these and whether they really are a single variable or whether we're trying to wrap many things in, and a category like sea ice is actually 2 or 3 variables. Nonetheless, this was the list that we came up with. I'm sure there are other ways to lump and split, but this is, again, the thought process behind this, I think, is equally important as the actual list. So let me continue with our thinking. So one challenge then is how do you get the right number of, or the right key variables? If we look at something like human impacts and pollution, we had a lot of discussion then about, well, what do we mean? Is it sources? Is it emissions? Is it concentrations? Are we looking at the processes that might influence concentration? So even if the emissions and sources stayed the same, if the ecosystem processes that produce biomagnification change, you could get different concentrations of pollution in say, the upper trophic levels. Is that what we're after? How does this relate to nutrients? In some cases, too much of a nutrient becomes pollution, or one type of pollution may function as we think of it as pollution in one sense, it may be a nutrient in another. Are we talking about pollution from outside the Arctic or just things within the Arctic, et cetera? And so how exactly, if we're trying to characterize pollution, what exactly it is it that we're talking about? And maybe pollution levels is the levels of pollutants in the environment is the better term. We also thought about things we didn't include. So turbidity is an example. So should it be, it has a couple effects. One is if the water is less clear, it'll affect the ability of light to penetrate down into the water column. So perhaps that aspect of turbidity is already captured in the variable of light. The particulate matter that's causing producing the visible effects of turbidity, that might have an effect on, say, nutrients or other biogeochemical things, but that might be covered in some of the columns that have to do with particulate matter. And so if the aspects of turbidity that matter to us are already captured somewhere else, then perhaps we don't need turbidity by itself. Again, the type of thinking that we were going through in coming up with the list. Next question is, how do we define the interactions? Now we're decided to concentrate on direct interactions, and I'll talk more about that in a moment. But this is, if A goes up, then B goes up or B goes down. And the middle part there, these could be the same direction, A goes up, B goes up, the opposite direction, A goes up, B goes down, or there could be no effect. A changes and it really has no effect on B. We did spend a bit of time talking about the language here. I mean, we'd often call this a positive interaction if A goes up and then B goes up. And if A goes up and B goes down, it's a negative interaction. But of course, positive and negative have other connotations, and so that may not be a great descriptor if people think, well, positive is a good thing and negative is a bad thing. So as examples of these kinds of interactions, if nutrients go up, we would expect other things being equal, primary productivity to go up. If stratification goes up, we would expect the availability of nutrients to go down and therefore primary productivity to go down. Now, we also thought about indirect interactions, and we decided to leave them out. Now, I think it's not hard for most of us to think of a chain of interactions, so it would produce an indirect outcome between just about anything in the set. And if we did that, we'd wind up with a horrendous plate of spaghetti, even worse than what we came up with anyway. So as an example, stratification in and of itself doesn't really have a direct effect on fisheries. The fishing boat can still go out, they can still deploy their net. It's not that stratification affects the way that fisheries are conducted. It's a chain of direct effects. So stratification would reduce the availability of nutrients, reduce primary productivity, which presumably reduces the abundance in higher trophic levels, which then has an effect on fisheries. So if we've done this right, then the direct interactions that we've listed should capture this chain, this indirect interaction that leads from stratification to fisheries. And that is something of a test. If we find that when we change stratification, it has no effect on fisheries, maybe we've missed something. Then the question is, how do you assign the magnitude of the interactions between the elements? And we came up with a three-tier system, minor, medium, and major. Could be either the plus, the A goes up, B goes up, or the minus, A goes up, B goes down. And then we spent a bit of time discussing, well, what constitutes minor, medium, and major. And our result was that this is relative to the other things that influence that dependent variable. So in the example shown, nutrients and primary productivity, if nutrient availability is really the biggest factor, or one of the biggest factors affecting primary productivity, then that should be in the medium or probably the major category. If it's a relatively modest influence, then it becomes say a minor or perhaps a medium influence. And it's possible that some of the influences here, the biggest influences, are outside the Arctic. So if we look at pollution, for instance, if we're considering pollution coming from outside the Arctic, then the influence of things happening in the Arctic may not be particularly large on pollution. Or tourism, if the Arctic is a draw for tourism, but the state of the economy and people's ability to spend discretionary money may be a bigger factor, so that the things inside of our matrix of interactions may not be the major influences, and that may be reflected in the way that we characterize the interactions. Next is uncertainty. Of course, there's a bit of guesswork involved in some of this. So we decided in the matrix that I'll show you in a moment, there are ways that we can indicate uncertainty. If we're not sure whether there are effects or not, a 0 would indicate no direct interaction. We could put the 0 in parentheses and say, we think that this is the case. In other instances, we're pretty sure there's an effect, but we're not sure which direction. So we could put a minus and a plus in parentheses. And then where we're sure there are effects, we're sure of the direction, but we're not sure how large, you can reflect that uncertainty in putting an extra plus or a minus in parentheses. And there's some examples at the bottom of some of the interactions that we put in those different categories. So here's the result, and I think this is cut off on the right-hand side, so it doesn't have everything. But this is the 5 categories, the 22 elements altogether. Remember that we're looking only for the direct interactions, not the indirect ones. And with the pluses and minuses and the numbers of pluses and minuses and the parentheses, we can indicate the direction of the interaction, the magnitude, and our uncertainty about it. And so once we had put this together, we all went through this entire matrix and started to give our idea of what we think is happening with each one of these, and then came up. So again, just to explain it a little further, the columns are the independent variables. So if we look here, it's clouds is the first one. What effect does clouds have on the rows of the dependent variables, on precipitation, on storm mixing, on atmospheric gases, etc.? And by having it going both ways, it means that we can distinguish between the way sea ice affects light versus the way light affects sea ice. So sea ice affects light to a great extent. Light probably doesn't affect sea ice that much. We wanted to be able to make those distinctions. We then went through wondering whether this made sense, looking at a course level, just how many things are affected by each of these and how many other elements each of our elements affects, if that makes sense. And what we found, somewhat reassuringly, was that the freshwater cycle, the sea ice, and temperature were the ones that seemed to have the most effects on other elements, and that made a certain amount of intuitive sense. And of course, if we consider the indirect effects, that number would go up quite a bit, and we'd expect to see that cascading effect. So this seemed to make sense, and it seemed to suggest we were on something of a right track here. As I said, this is something of a work in progress. We have a few things to do. Are there dead ends where A affects B affects C and then nothing happens? And is that a reasonable outcome? Are there elements that really seem to be prominent in the cascades? If we change one a little bit, it winds up having a big system-wide effect. I think that gets into something of a network and sensitivity analyses. Are there nodes? Are there particular pathways in here? Are there elements that a small change in one seems to have a big change elsewhere, versus elements where there's you change it all you want and it really has very little effect on the ecosystem as a whole. So to recap, starting with our discussions and our sketches and so on in Solomon's, coming up with the matrix, and then looking at the way that making those connections and coming up with the interactions. And finally, thanks to the services of the KAUST, the King Abdullah University of Science and Technology, where Carlos is, putting this into an actual interactive network, where you can start to to play with some of these ideas. And the idea behind the diagram in the lower right is to capture things not in an immediately comprehensible way. It's a bit complicated, but it does give you the chance to look at how different things interact. And because it has the model underneath it, I think you can then start to conduct some of those tests and network analyses. And so we wind up with this as the visual representation of what's going on. And as I said, there's the model underneath it, so that you could then go through and start to look at what happens when you tweak one and how that ramifies through the system. And that's something that needs to be done. Anyway, that's where we've gotten to. I think this has produced some interesting things. We found it to be really interesting and challenging to think through exactly what we were looking for and exactly how those interactions played out, because it was very tempting to have a whole lot more interactions than probably actually exist, and also very tempting to say, well, we're really not sure. And we tried to resist that. In many cases we aren't sure, but we should know enough to be able to say something. And so how far are we willing to push our understanding of the system and commit ourselves to saying, yeah, this is actually an interaction where if A goes up, B does go up, and no, it's not a major interaction. This is a minor one, or yeah, this is really a big one. So I'm sure different people doing this may have come up with a different result, but I hope that the overall characterization of the system would be at least broadly similar, and that exercise is a fruitful one for stimulating further thought. There we are. Thank you very much.
Thank you, Henry. That was very informative and it's fascinating, actually. Are there any questions over the phone or in the room here?
Hey, good morning. This is Kathy Kuhn in the Alaska region of Bohm.
Hey, Kathy.
And hi. Hey, if you could go back to the previous slide, I think I just want a better understanding of how one might read or interpret the graph. And I just want to look at the pollution one. So initially I was interpreting positive effect as, well, something positive or beneficial, but really what you're saying is there would be a net gain. So if you look at pollution, and that's most predominantly green lines coming out of that that reach into some of the other categories. It's basically saying there's a net like increase, net positive increase, not something that's beneficial from pollution.
Right. As I mentioned, we were struggling with that terminology because you're right. Positive effect sounds like, hey, that's a good thing. In this case, what we simply mean is that if pollution goes up, then the dependent variable would also go up. And that involves a judgment call. So if we look at, for example, the connection from pollution to policy and management, does an increase in pollution lead to greater awareness of the sources and problems? Take an example, the persistent organic pollutants. The AMAP report in 1998 helped draw attention to the amount of pollution that was in the Arctic. That was one of the factors that led to the Stockholm Convention on POPs, which we would regard as an intervention that in policy and management. So the increased level of pollution led to, again, an increase is perhaps not the right word, but I think you see what I mean, a management intervention. So an additional action in policy and management related to pollution. So in that sense, we saw that as what we're calling here a positive effect.
Hey Henry, this is Francis.
Hey Francis.
Hey, thanks. That was really interesting, and I think I need to stare at those matrices and interaction stuff for some time, because there's clearly a lot of stuff that's underlying them to really understand it all. But I think the approach is really cool. I had one specific question. If you go back to the summary matrix where you had like the numbers of things influencing each other and affected by that little table.
This one.
Yeah, exactly. So, we can see, for example, if, affected by, for example, or affecting, if you look at some of the human ones, like development that has an 8 in there, and pollution that has an 8 in the other column. I was wondering, for some of those anthropogenic activities, whether here you are also trying, or what the assumptions are, I guess, that went into different scenarios of those activity levels, because those interactions and impact, of course, may vary with if you dial that up or down. And that's kind of tricky to figure out what that might be as well as represent here. So I was wondering if you had any discussions about that.
Quite a bit of discussion, and some of that centering on which of these things actually have an effect at the pan-Arctic level. So we can imagine a rogue cruise ship that dumps a bunch of raw sewage into part of the Arctic. Yeah, that's a local mess, but unless you have thousands of these ships, you're not affecting the entire Arctic system. So it probably, for our terms, that doesn't really count. And so, we thought about that with things like development. I mean, how much development does it take if we're thinking about, say, mines and oil fields and other infrastructure things and so on? Yeah. How much of that does it take to start to have an effect at the level of the Arctic ecosystem? And the answer is probably quite a bit. And then with something like tourism, I mean, how much does increased cloudiness, is that really something that would deter a lot of tourists from coming up to the Arctic? Presumably tour ship operators don't show pictures of cloudy days in their brochures, but just how cloudy does it have to be before somebody says, yeah, forget it, I'm not going there? So there was quite a bit of thing. And take fishing as another example. Sure, if we know worldwide that fishing can have a huge effect on marine ecosystems. How much fishing has to go on in the Arctic before you would start to see that kind of effect at the ecosystem level? So again, I'm not claiming by any means that we got any of this right. And that's what I said at the beginning. I think the thought process to us was very instructive in forcing us to confront a number of assumptions and easy connections that we had made and think, well, does that really make sense, and can we really back it up?
Yeah.
So I have no problem with anybody critiquing our choices and changing things, and in fact we welcome it. But I invite you to anybody to to dive into that kind of thinking and see where it takes you.
Yeah, no, thanks for that. And just as a quick follow up, I think the best we can do, of course, is to do a snapshot really of the current assessment of what those interactions are and effects might be based on what we know now, and that's assuming the same mechanisms hold true in the future and with some sort of an idea of what current impacts are. And in that sense, it's always interesting perhaps to think about this interaction matrix, which is a really cool approach, and have like a current and a future one, depending on different scenarios, at which point you are merging a couple of different approaches into a same framework.
Exactly. And that, if you remember on the opening or the slide of that whole poster of the matrix in the lower left, there was the state of knowledge exercise. And that was also a very interesting one. Just how big an influence does this element have on the rest of the system? How sure are we about our knowledge, and how fast is it, or how much is it really changing? Again, these things all sound like pretty straightforward questions until you start to wrestle with committing yourself to an answer on one particular element or another.
Yeah, thanks.
Are there any other questions for Henry? Henry, maybe this is a question for Carlos, but you might know something. I understand that there is going to be a web tool that is going to be interactive. What's the latest on that? What's the status, if you have any information?
I think what I know is exactly what you just said, that there is supposed to be an interactive web version of this, and I don't know when it'll be available.
Okay, I will reach out to Carlos. Thank you.
I do know that Carlos right now has been assembling bits and pieces from the different teams working on different things, like we were working on this matrix, to put together a paper introducing the whole conceptual model. And I think that's probably taking up much of his time right now.
Sure. Thank you.
Yeah. Thank you very much.
Thank you.